Hello, everyone. I'm sure all of us have here heard the term climate change. These days, we have a rise in the frequency of events such as rains, droughts, cloud bursts, and so landslides. And one word which we commonly hear while discussing them is climate change. Now, whether these events occur due to climate change or not is a completely different story. But what here I am going to talk about is how do we know how do we understand this? So so if you see the plot here, these kind of model projections, they try to predict the future. And the policymakers who make the policies for a better future use these projections as a basis for the same. These kind of projections are also suggesting that we will have a changing climate, and we are in a changing climate, and we'll have a climate which will have more hotter events in the future. Now, where does this come from? I'm saying model projections and model is suggesting this and that. So these come from climate models. What are climate models? Climate models are actually a mathematical representation of all the physical, biological, and chemical processes occurring in the Earth system. Now, when we are trying to represent these processes in terms of mathematical equations, a lot of intricacies are being lost. And this is what induces the error in these models. Now, policymakers are using this to make policies. We are relying on this. This is coming from climate model. If climate model is not correct, how do you trust this? Since this is very important, we need to have a better this, right? So that is one of the broad areas in which my PhD has focused, that we know that there are errors in this climate model. We know that they are inherently there. Now, what if we try to quantify the impact of this error? If we can do that, can we correct these projections and have more confidence in them? That is one part of the thesis. The second part of the work is improving a physical process, the upper ocean mixing process, which is a very small scale process in one of the ocean model, and understand and seeing if it has any impact in improving the model state. So the methodology adopted here in order to quantify the impact actually is to using the concept of baroclinicity. So, this ocean can be actually decomposed into a set of mathematical modes which will govern the dynamics of the ocean. This is very similar to a spring mass system where the motion is governed by the spring constant of the spring. Very similar to that. So using this concept of baroclinicity, we calculated the wave speeds in all the models, and we found that the models have a different mode structure, and therefore different dynamics are being evolved there. So this is a very important study because this was also quoted in IPCC, saying that this is one of the first kind of a work which is talking about the impact of errors and can have real implications. So we quantified the impact using wave speeds here. Now, after doing this, we went on to develop really an ocean dynamic thermodynamic model. It's a very simple model. Now, you see, we have these climate models. They are very sophisticated, very complicated. They have interlinked feedback, are a representation of all processes together. So understanding the impact of one process or of one parameter, doing one tuning, what can it do really, is very difficult physically. So another method to do that is you take a simple framework in which there are only few things, and then you tune your parameter, you see how it is changing everything. If you have minimal representation, you have a better understanding. So that is the concept which we applied here, and we tried to develop this model, and we understood the mixing in the Indian Ocean using this model. And thereafter, after understanding how the mixing processes are, we try to resolve this process something called reversible fluxes. We try to eliminate it from the calculation of mixing in one of the ocean models. Now, this is a very small scale process, as I said in the beginning, but it shows promising results because it improves the turbulent fluxes, and it has, at least in one-dimensional ocean model. We plan to test it in 3D and take it to Earth system model. So basically, in the first part where we studied the impact, the quantification of impact of errors increases the confidence in projections. Then we try to understand the mixing processes, and we try to resolve one such process which helps in improving the representation of turbulent fluxes. Now, even though it was a very small scale process, these set of small scale processes help in resolving the large scale processes better. Thus, this kind of study can help in improving the climate models. Therefore, the title of my thesis is a modeling study on upper ocean processes, mixing dynamics, and deep ocean biases in tropical Indian Ocean. Thank you so much.